Okay, let's look at question number 3 now. A curve has the equation of x to the power of half plus y to the power of half is equals to 3, and we are told that x must be positive and y must be positive. Both must be greater than 0. It means both values should be positive. So we need to show that the first derivative dy dx is equals to negative y over x to the power of half. Since in this expression we do have x as well as y, so we're going to do an implicit differentiation in order to get this dy dx. So that's what we're going to do now, right? So first, x to the power of half plus y to the power of half is equals to 3. That's what's given in the question. So now let's differentiate this entire expression with respect to x. Of course, x to the power of half, if you're going to differentiate with respect to x, you're going to bring the half to the front and you're going to subtract 1 from the power. So half times x to the power of half minus 1, which would become simply half x to the power of half minus 1. That should give you minus half. So there we have differentiated the first term. Now let's go for the second term, which is y to the power of half. So for this part, we're going to do it implicitly. So we're going to bring the half to the front and we're going to subtract 1 from the power, and then we will differentiate the y and write it as dy dx. So half y to the power of half minus 1, which is minus half. And if you differentiate y with respect to x, that's going to give you another dy dx. And of course, when you differentiate a constant, okay, it should give you a 0. So 3 differential will become 0. So we have the differential equation over here. All that we need to do in order to show this is to make dy dx the subject of the formula. Of course, the first step what we can do is we can just multiply throughout the expression by 2 in order to get rid of the half here, right? So 0 times 2, 2 would also become 0, right? So I'm going to multiply everything by 2, so all the half and half are gone. So I have x to the power of minus half plus y to the power of minus half dy dx is equals to 0, because 0 times 2 is also 0. So now since we need to isolate dy dx on the left, so we're going to throw the x to the power of minus half to the right. So of course x to the power of minus half means, okay, is 1 over root of x, but now it's a plus this term, so I'm going to throw it to the right hand side. It would become minus x to the power of minus half. So now we have this y to the power of minus half as a multiplier for the dy dx. So when I bring it over to the other side, it's going to become a divider. So 1 over, okay, what I have done here is I have changed it into indices form. 1 over y to the power of half dy dx is equals to negative 1 over x to the power of half, right? So now we have y to the power of half, which I can cross multiply over to the right hand side. So the numerator would become, okay, 1 times y to the power of half would simply be y to the power of half, and then over x to the power of half. And by rule of indices, since both of them have got a common power of half, we can pull out outside the bracket and write it as this, and that would be the way that we are expected to show. And once you pull out the half, okay, you have shown it exactly as what is needed. So if you have done this correctly, so you would be getting 2 points. Now let us move on to part B, which says find the equation of the normal to the curve at the point when x is equals to 1. Of course, when you look at the word normal, we know that we need to find out what is the gradient of the tangent. So it's easy for us to go for the gradient of the normal by taking the negative reciprocal of the tangent. So x to the power of half plus y to the power of half is equals to 3. That's the equation given. And of course, you may be wondering, why am I copying down the equation? Because if I want to find dy dx is actually in terms of y and x, right? But we are told when x is equals to 1, if we can find what's the value of y, we could just straight away substitute here, and that would make it easy for us to get the gradient of the tangent easily. So substitute x equals to 1 into the equation. So x is equals to 1. Of course, power half means square root. So this is root of 1 plus, okay, root of y to the power of half means root of y equal to 3. Square root of 1 is of course 1 still. And if I throw the 1 over to the other side, it's going to become minus 1, right? So 3, if you subtract the 1, it's going to just give you 2. But what we need is the value of x, value of y. So if there is a square root, if you bring it to the other side, it's going to become a square. So therefore, y would become 2 squared, which is 4. So when x is 1, y is a 4. And of course, what do we do with the x and y? We can find what's the value of the gradient, right? dy dx. Substitute x equals to 1 and y equal to 4 into what we have already proven earlier, which is y over x to the power of half. So the value of your y is 4 and divide by 1 to the power of half. So which is simply going to be minus 4 to the power of half, because 4 over 1 is a 4. And 4 to the power of half is basically a square root of 4. So when we square root of 4, it's going to be a 2. So therefore the dy dx, which is the gradient of the tangent line, is going to be equals to negative 2. So now we have the gradient of the tangent, but what we need to find is the equation of the normal, right? So what is the relationship between the gradient of the tangent and the gradient of the normal? Of course, both of them must be perpendicular to each other. And if two lines are perpendicular to each other, the product of their gradients should be giving you a negative 1. So the gradient of the normal should be the negative reciprocal of the gradient of the tangent, which is minus 2. So we're going to take, okay, half. Okay, if you take a half and you multiply by minus 2, it's going to end up giving you minus 1. Or alternatively, minus 1 divided by minus 2 is going to give you positive half. That's the gradient of the normal. Since we got the gradient of the normal, okay, the equation of a straight line should be of the form y equal to mx plus c. So the m is of course equals to half, so which we have already found. So half x plus c. And in order to determine the y-intercept, we need to know one set of coordinate that the line passes through. We know that when x is 1, y is a 4, and this is the point of tangency, or the point at which the normal is going to cut through the gradient, cut through the curve. So therefore we could, the normal will also pass through this point. So we could use this coordinate to substitute into the y and x, and we can find the value of the y-intercept of the normal. So substitute 1, 4 into the equation of the normal. So y value should be 4 and x value should be substituted with a 2, with a 1. So 4 is equals to half of 1, right, plus the constant c. So 1 times a half is half. Half, if I throw it across to the left, it will become 4 minus a half, which would become 3.5. So the value of your c should be 3.5. That is, in improper fraction, is 7 over 2. So there we have the value of the y-intercept. So since we got that, let's take this value of c and let's put it back into the equation of the normal. So hence the equation of the normal would become y equals to half x plus 7 over 2. And of course we can get rid of the denominator 2 by multiplying throughout the expression by 2. So this would become 2y. Half of 2 is 1. So that should be a 1x, so which is x plus 7. So let's look back. Okay, find the equation of the normal to the curve at x equals to 1. So this is the equation of the normal to the curve at x equals to 1. And that question is completely done. So if you did it this way, so you would have gotten 4 marks for this question.